Hi guys, in this video we are going to learn an interesting question from electrical fundamentals. Also we are having a circuit which contains R and C, which simply means resistor and capacitor. Also we have mentioned that it has been connected in series. Also I have mentioned some details, so please copy down and I will read the questions. After that you can pause the video and try it in your own. After that you can see the rest of the video and check your answers with my answers. So I'm going to read the question now. Before that, just copy this information. In a series circuit, R is equals to 3.3 kilo ohm, C capacitance is equals to 2.2 mu F, and I, the current, 4.73 sine 240t plus 75 milliampere. Find total impedance of the circuit in Cartesian and polar forms. So they have asked to find the impedance, total impedance of the circuit in both forms, Cartesian and polar forms. Hope you can try this in your own, and after that just see the rest of the video. Hope you have tried this. There are many simple ways, but I'm going to go from the basics so you can easily get an idea how to do this, how to tackle these questions, or the questions which is little bit difficult than this one. So in this case, first we need to know, when we are having a series circuit, as we all know, the same current is going to pass through R, which means resistor, and capacitor. So we can directly tell we are going to take the reference line as I's phase. So I'm going to take the reference as I's phase. As I have mentioned, why I'm taking this is, in the series circuit, we all know the current is common for both things. So there won't be any phase difference between the current. However, the voltage would be different, but we know how to tackle that one. So when we are considering the resistance, just I'm going to draw a rough. So it's like this. So when we are talking about the voltage, as we all know, the phase difference between voltage and the current for resistor is 0. So we are going to draw like this. So this is the voltage line. So it's not a problem if you draw the voltage line less than I, but normally voltage we are going to draw as big. It's not a problem at all. So after that, I'm going to draw the voltage for the capacitor. However, we know that I leads the voltage in capacitor. So just remember this. In inductor, if you have an inductor in a circuit, we should remember the voltage will lead the circuit, will lead the current by 90 degrees. But if we are considering the capacitor, we always should remember that the current is going to lead by 90 degrees. So I have mentioned that this is the current. So I'm going to draw that as a perpendicular line below. So if I mention this V1 is going to be V2, just remember that this is the line which lags the current. In other terms, we can tell that the current leads the voltage by 90 for capacitance. Just try to remember that. We don't need to put these diagrams for the exams. However, I'm just telling to get a basic idea of that. So when we are considering the Z, which means the impedance, we all know the impedance of, I'm going to take this as 1 and this is 2 circuit element. When we are considering the impedance of the first element, resistance, we all know the resistance imaginary part would be 0. As it only contains the resistance part, the imaginary part, which means the reactance, would be 0. So I have mentioned here that the R is equals to 3.3 kilo ohm. So I'm going to put this as 3.3, but be careful of the units. So I'm going to mention 10 to the power cube ohm. After that, I'm going to find the reactance of capacitor. For that, you should remember what's the equation for that. So when we are considering, if we consider that, it would be equal to minus j over omega c. It's not a big deal. The real part of the reactance of the impedance of the capacitor would be 0. But when we are considering the imaginary part, which means the reactance part, it's going to be in the line of B2. So we need to put minus sign over here. And when we are considering the imaginary part, which means in the y-axis direction, we need to put the j, and we also need to remember 1 over omega c is going to be the impedance of that. So I have just mentioned here. So the final part is we need to adapt them, because as we all know, when we are finding the impedance in a series circuit, we need to adapt both things. From that, I am going to find this. However, I don't know the omega value, but they have given the capacitance value. So finding the omega value, they have given the equation of the current, as we have given 4.73 sine 240t plus 75 milliampere. However, we know that any equation, the format of any I or V is equals to the maximum value of the voltage and the sine part, or maximum value of the current and the sine part. However, they are given that into the sine part, omega t plus 5. As I have already written like this, 4.73 sine 240t plus 75. However, there is a milliampere, but it doesn't matter because we are going to take this part. Why are we taking this part is, the reason is, as we all know, this would be the peak value of the voltage or current, but in this case, it would be the current peak value. And inside this, sine 240 is equals to omega plus this is the 5. That means initial phase of this current. So if I substitute this, I can directly get 240 into the C I have already given 2.2 10 to the power minus 6. So I have figured out, but you need to solve this using calculator. If you solve this, you will get an answer of minus j 1894 ohm. So I have finished the first part. But I need to find the total impedance. For finding the total impedance, as I already mentioned, for finding the total impedance of a series circuit, we need to add both. If we have 3 impedances or 3 circuit elements, we need to find the impedance for each element, and we need to add those 3. However, we have given the 2 elements, so we need to add these 2, Z1 plus Z2. If I add this, the real part is only, the Z1 is only having the real part, so it would be very easy for me. That is equal to Z1 plus Z2. As I mentioned, 3.3 into 10 to the power 3, which means 3300 plus, sorry, it would be minus because the imaginary part is having the minus sign, so I'm going to write it as minus, and the imaginary part's value would be 1894. So 1894 J, don't forget to put the unit, it would be omega. So I haven't written all the things, but here they have asked the total impedance in both forms, which means Cartesian and polar forms. But here I have given only the Cartesian form. However, we need to change this to polar form too. As we all know, we can easily change that by using the Pythagoras theorem. As we all know, if we draw the phasor for this, 3300 would be in the x direction, and here is the minus sign. So when we are considering the y-axis, it's going to be in the downwards direction, which simply means 1894. So if I draw a line like this, I'm going to get an answer for this phasor. We can directly find using tan phi is equals to 1894 over 3000, but careful, you need to take the minus angle as it's in the fourth quarter. But here we can directly find this using Pythagoras theorem. However, in the exams it would be difficult to find these things using Pythagoras theorem and tan values. So you can directly use calculator for finding this value. I have already uploaded how to find or how to change the polar form to Cartesian forms or Cartesian form to polar forms, and how to simplify the equation using complex numbers. So I have already uploaded the video. So if you haven't watched that, I have given the link in the description, so you can always watch that. Hope this video would be useful. If you like to watch any other videos related to electrical fundamentals, I have given our website link in the description, so always you can watch that. It's for full free. If you like this video, don't forget to subscribe it. If you have any doubts, just comment below. Thank you.